Mark your own, here we go. Good old Ann. So what kind of questions can I ask you on the written section specifically? On the multiple choice section, I guarantee there's going to be a question where I do something like this. So electric force is little k, Q1. I have trouble doing a lowercase q, so I'll do them as big Q1, Q2 over R squared. What's little k? So I'm not going to ask you to find that, but there will be a multiple choice question where I give you one of 1, 2, 3, those four. I give you 3 of those 4, and I ask you to get it by itself. In fact, now that you're done dropping your pen several times, I almost certainly won't ask you to find FE. I'll give you FE, and I'll give you charge 1 and R, and say find charge 2. Or I'll give you FE and say find charge 1, give you charge 1, charge 2, find R. So there'll be something like that on the multiple choice. What else will there be on the multiple choice? There will be an electric field diagram question. Make sure I don't forget to talk about the electric field diagram question. I'll show you an example of one a bit later. What else will there be on the multiple choice? Probably a conceptual question where I give you a picture of some charges in an arrangement, and I say, this charge right here, what direction is it feeling a force? You don't have to calculate it, but you got a charge here, here, which way is it feeling a force? It's, like charges, unlike charges attract, and figure out how to add the vectors tip to tail so that you get the correct direction. I won't make you do the calculations. What are you going to see on the written section? Absolutely, there's going to be 2 points. What can I ask you if I give you 2 points in this configuration? Well, I could, like A, ask you just to find the magnitude of the electric force. Electric force is K, Q1, Q2 over R squared. Oh, it's also Q times the electric field, but that would be if I knew the electric field right there and I placed a little charge right there. That would tell me the force on that charge right there. It would not tell me the force between these two. It's going to be little k, Q 5 microcoulombs, Q2 3 microcoulombs, all over 2.35? Ugh. Don't forget the squared. This is not going to work out nicely. I don't know. I haven't done it yet. 9 times 10 to the 9th times 5 times 10 to the negative 6 times 3 times 10 to the negative 6 divided by 2.35. Don't forget the squared, Mr. Dewick. 0.0244, is that what you said?
Yeah.
Okay. Newtons. I would give you probably 1 mark for that, half mark for the number, half mark for the answer. Gotta be honest, that's a little easy-ish for your test. So I don't think I'll blatantly just say, calculate the electric force. I might ask you to find the force on 1 charge from 2 charges, and I'll show you an example of that, make sure I don't forget. But what else can I do with 2 charges? I absolutely will ask you B. I'm telling you a question on your test right now. There's going to be a question on your test where I ask you to find the electric field created, the overlapping electric field created by 2 charges. And I'll either do it between the charges or over here or over here. What I mean by that is it will be linear so that you won't have to add the vectors tip to tail. You can just go winner minus loser. How am I going to find the electric field magnitude and direction at location A? I'm going to find the electric field from charge 1, which is K Q1 over R1 squared, which is K 5 microcoulombs all over 1.5 squared. The electric field from charge 1 is a magnitude of 20,000, is that right? Direction. How do I figure out the direction? Zijun, I cover up this charge in my mind. I ask myself, which way would a positive sitting right there, and why positive? It's defined that way. Which way would a positive right there want to move because of this guy, left or right? Well, one of those. Someone said left, someone said right. Unlike charges. So I'll write a left. You could also call it west, but I get east and west mixed up. Okay? Then I repeat for charge 2, magnitude and direction. It's going to be K, charge 2, all over 0.85 squared. I can just do a little backspacing and editing. And I get 37,370. Oh, and I wrote newtons. That should be newtons per coulomb. Thank you, Mr. Dewick. Newtons per coulomb. Which way? Which way would a positive right here want to move because of this guy? Also left. So I guess it's going to be left plus left. The final electric field is going to be this plus 20,000. It's going to be 57,400 if I go to 3 sig figs. 57,400 newtons per coulomb left. How would I mark this? I would give you a half mark for this magnitude. I would give you a half mark for that magnitude. I would give you 1 mark for the 57,400, and I would give you 1 mark for the direction. What if there was 3 charges and I asked you to find the overlapping? Well, now that you can do 2 charges, Alicia, you can do 3. Do the third one, magnitude and direction. Is it left? Then add it. Is it right? Winner minus loser. Is that okay? Yeah, yeah, yeah. Yeah, yeah, yeah. You lying? No? Good. Alicia, what's C want me to find? Oh, this is easy. That's going to be K Q1, Q2 over all. Is it? What did I just write down? I will ask you to find the electric potential from 2 charges, the overlapping electric potential. And unfortunately, some of you are going to find the electric potential energy. And it works. You've got 2 charges sitting there. You can just plug and chug. Unfortunately, you'll get a 0 on that question on the test. Because that's nice that you found the potential energy. Thank you. Not what I asked for, right? If I go to a restaurant and I order a steak and they bring me fish, I'm not paying for the fish. Not what I asked for. Fish might be good. I'm not paying for it. So how electric potential? I'm going to find the potential voltage from charge 1. I'm going to find the voltage from charge 2. And then I'm going to add them together. It's going to be K Q1 over R1, no squared. In fact, because my calculator lets me backspace and edit, I think it's going to be this right here with no squared. It's going to be 9 times 10 to the... Oh, no, Mr. Dewick. You include negatives and positive. It's going to be negative 5 microcoulombs divided by 1.5. This is going to be a negative voltage. So I better type this from scratch. 9 times 10 to the 9th, negative 5 microcoulombs divided by 1.5. And I get negative 30,000 volts at location, what did I call it, X? Location A, negative 30,000 volts from this charge. What about the second location? It's going to be K Q2 over R2. It's going to be 9 times 10 to the 9th, positive 3 microcoulombs divided by 0.85. 9 times 10 to the 9th, 3 microcoulombs divided by 0.85. I'm going to get positive 31,765. How will I add these together? They're scalars. I just add them. What's the voltage at this location? I can do it in my head. It's going to be 1,700 and I guess 60. If you said 70, I'd give you credit, but 1,760 volts if I go to 3 sig figs. What if both these charges were identical and I was halfway between them? The electric field would not be zero, but the voltage would be zero. Why would the voltage be zero? What that means is to move a charge from that location, already right there, it's no energy, has no energy per coulomb. Okay? So that's kind of what I can do with two charges if they're in a nice straight line. What else? Here's another nice written question. How much what? There will be a work question where I ask you to find how much work. Can we just go force times distance? This is why I told you when I taught you the work energy theorem, it's a longer one, but it's way more flexible. Work is going to be the change in potential plus the change in kinetic. If I gave this to you on a test, I would say, assume the charge begins and ends at rest. Here we have to make that assumption, but I don't see a V anywhere here, and I don't see them asking me to find a V, so I think I can make that assumption. What's change in anything?
Final minus initial.
So this is going to be PE final minus PE initial. Oh! What am I trying to suggest there? So am I starting there or ending there? Oh, this became way easier. The work is going to be K Q1 Q2 over our final. Gotta be honest. For 4 marks, this is a bit too easy. If I was giving you this on the test, I wouldn't start you out at infinity. I'd start you somewhere close by so that this wouldn't cancel. It's going to be 9 times 10 to the 9th. Q1, 8 micro... Or is it? Do I put the negative in for energy or not? Oh, okay. Q2. It's an electron. All over 0.15. No idea what the answer is. Negative 8 microcoulombs times negative 1.6 coulombs divided by 0.15. Do you get 7.68 times 10 negative 14? Units, I guess joules or Newton meters, because force times distance, but joules. If you got that, 4 out of 4. Otherwise, I guess 1 for that, 1 for that line, 1 for that line, 1 for the answer. This is a little easy, I think, for 4 marks. But number 3 had some teeth. A proton initially at rest will have what speed at point Y? Is this asking how much work? So how am I going to solve this then? This is conservation of energy. This is like dropping an object and using energy to find out how fast it's going to hit the ground, except stuff falls up. Okay. KE initial plus PE initial equals KE final plus PE final. Oh. Yay. Oh, okay. K, big Q, little q, over R initial equals a half little m V final squared plus K, big Q, little q over R final. I guess I'm going to find that. So K, big Q, little q over R initial minus K, big Q, little q over R final. That equals mv squared over 2. That's a terrible 2. I could times by 2, divide by m square root, and do this all in one step. But if you did, go ahead. But I think most of you will find it easier to crunch that. In fact, I think I'm going to use my world-famous ditto marks. I had an email from a teacher who's using my notes. What the heck is that? What are those X's? Are the X's standing for something? She hadn't watched the video, clearly. And I get it. I mean, I don't think you're going to see that in any university course or anything. So don't do it with your profs next year without explaining to them what you're doing. K, big Q, 5.5 times 10 to the negative 6. Little q. It's a proton. All over 1. Don't forget this. No squared, Mr. Dewick. Minus K. Oh, you know what? Minus same thing times same thing times same thing all over. One of the most common mistakes that drives me a little cray-cray is when I see kids say, oh, R final is 2.5. What is R final? 3.5. Please measure the entire distance. Okay? That equals mv squared over 2. Let's crunch the left one. 9 times 10 to the 9th, 5.5 times 10 to the negative 6 times 1.6 times 10 to the negative 19. I know that dividing by 1 isn't going to change the answer, but I'm going to divide by 1 so that I can backspace in the second one. But I have mocked many of you for timesing by 1 or dividing by 1, and I will say to you, I'm doing this deliberately in the full knowledge that it's redundant, so don't tell me that I don't understand my calculator. I get 7.9, is that right for the first one? 7.92 times 10 to the negative 15? Eesh, that's messy, Mr. Dewick. And then minus backspace, just change the 1 to a 3.5. Yeah. 2.263 times 10 to the negative 15. That equals mv squared over 2. 7.92 times 10 to the negative 15 minus answer button. I get 5.657 times 10 to the negative 15. That equals mv squared over 2. What did I hear you whisper a few seconds ago? Times by 2. Divide by... Ooh. It's a proton. Square root times by 2, divide by 1.67 times 10 to the negative 27, and I get... Oh, we're going faster than light. That's impossible. Whew. Square root 2.6 times 10 to the 1, 2, 3, 4, 5, 6. Let's go. If you got that, I would give you, what did I make this worth? 4. I would, by the way, on a test, this would be worth 7, so I could give out way more part marks, because this is a lot of work. 1, 2, 3, 4, 5, 6. I'd probably go something like this. Half mark if I saw that line. Half mark if I saw that line. Half mark for that. Half mark for that. Half mark for that. half mark for that. And then I think that's 3, right? 1, 2, 3, 4, 5, 6, and 1 mark for the answer, something like that. Mr. Dewick, who did this spectacular diagram? Look, they're harder to do than you realize.
I think it's beautiful.
This one here, I think I stole. So I don't know how to... Anyways. This one here I made up, and that took me like 25 minutes, and by then I was just tired. I'm drawing the next one. So here it is. We have an electron, and I guess the electron has an initial velocity of 6.8 times 10 to the 6th. Someone gave it a big push. As it moves to the right, it's going to get closer and closer to this negative charge. What's going to happen to the electron's speed? In fact, which way is it feeling a force? To the left. By the way, which direction is the electric field right by the x? Which way is the electron feeling a force? No. Which way is the electron feeling a force? You just answered that question 10 seconds ago. So which way is the electric field? Which way would a positive? Okay, that would be a nice test question, giving you the electric field that an electron experiences as a multiple choice question, and saying, okay, so which way is the positive would be in the opposite direction. Okay. Conservation of energy, G. That's 0. A half m v initial squared plus k big Q little q r all over r initial equals k big Q little q r all over r final. By the way, if you did want to get r final by itself, for what it's worth, it would be this. Don't write this down. R final is going to be k big Q little q all over a half m v initial squared plus k big Q little q over r initial. Because I could turn this into a fraction by saying that whole thing is one big fraction over 1, and stuff does move diagonally. I don't see the advantage to that. Which is why this is around where I stopped getting stuff by itself. Instead, I'm going to go straight to numbers. 0.5 m, it's an electron, 9.11 times 10 to the negative 31. V, 6.8 times 10 to the 6th. Don't forget the squared. Plus K, big Q, negative 5.5 times 10 to... Why negative? For energy, we include the negative. It's an electron, negative 1.6 times 10 to the negative 19. All over our initial 5. That equals K big Q little q over R final. Let's crunch this. 0.5 times 9.11 times 10 to the negative 31 times 6.8 times 10 to the 6th. Don't forget the squared, Mr. Dewick. And I get 2.106232. You know, I'm going to carry everything since it does end, and I want to make sure I'm not rounding off too much. So 2.106232. 2.106232 times 10 to the negative 17. Plus 9 times 10 to the 9th times negative 5.5. Microcoulombs times negative 1.6 elementary charge divided by 5. Is that right, Mr. Dewick?
Yeah.
So really, this is being dominated by the potential energy, not by the kinetic energy, which I'm going to guess it doesn't get very far. I'm going to guess of that 5 meters that it can close in with, it doesn't cover much at all, but let's find out. Really, Dewick, is that right? No, I missed. That's not right. There we go. That was creeping me out. How about 1.584 times 10 to the 1.584 times 10 to the negative 15. That equals K big Q little q over R final. Yeah, 10 to the negative 17, 10 to the negative 15, still fairly far apart, but nowhere near as far as earlier. So it's going to be that plus 2.10623 times 10 to the negative 17. Double checking for typos. 2.10622 times, it looks good. And I get that. I'm going to write 1.605, but I'll store it on my calculator. 1.605 times 10 to the negative 15th. That equals K, big Q, little q, over R final. Stuff moves diagonally. I'll get R final is K, big Q, negative 5.5 times 10 to the negative 6. Little q, negative 1.6 times 10 to the negative 19. All over answer button. Here we go. K, big Q, little q, divided by answer button. I'm going to check carefully for typos because I don't have a second crack at this. I think that looks good. Do y'all get 4.93? Yeah, because the kinetic energy was 10 to the negative 17. That's 100 times less than the potential. It's not going very fast. It's not going fast enough to move very far. If you got that right, I would give you 4 out of 4. Otherwise, 1, 2, 3, 4, 5, 6, 7. I would probably go half mark for that, half mark for that, half mark for that, half mark for that. That's 2. Half mark for that, half mark for that. That's 3, and 1 mark for the answer. Can you give yourself a score, please, out of 18?